Hello, this video is about an introduction to triple integrals. So the first thing is, what is a triple integral? A triple integral is an analogous to double or single integral, but then for single integral, the domain was one-dimensional. We would find the area over that domain. For double integral, we had two-dimensional domain, and we would find the volume over two-dimensional domain. For triple integral, we are trying to find basically however we interpret the net value, which is analogous to area and volume in 4-dimension, because area was a two-dimensional thing and volume was a three-dimensional thing, and then whatever that is in the 4-dimension. Imagining it is a little difficult, and so it would be triple integral is basically that over the triple integral of over a solid B of a function of 3-dimension, a function that takes a three-dimensional object in, and this part is called the volume element. It just tells you about the infinitesimal volume that will basically will contain the that we're taking the integral over. So speaking of that, how do we interpret this in terms of basically how do we interpret this in terms of Riemann sum? Riemann sum is going to be the if you remember, one dimension, it was or single integral was one sum, and we take the limit. Double integral was 2 sum. Here is 3 sums, and then you take the value of the function times the volume element, which is infinitesimal x, infinitesimal y, infinitesimal z, as the number of division gets smaller and smaller, basically. And so that's how it does work. Now let's go to the next page. So, and some of the ways to show a triple integral, we're going to discuss that later. But before that, any triple integral over a domain W, which is a solid W, and function 1, that's f of x and y and z, f of x and y and z equal to 1, is going to be equal to the volume W, volume of the domain. This is again, as we had every time we took the integral. If it was double integral over a region, it would be the area of the region. If it was single integral over an interval, it would be the length of the interval. Now, we have another formula that is interesting, and over here. So the average value of a function f of x and y and z over a solid W is going to be the integral, the triple integral over domain W of f and x and y over the volume W, and that gives you the average value. This is very much analogous to single and double integral again. So what do we talk when we talk about a triple integral? We don't mention what we mention is basically we're finding this stuff, the net stuff, within over of a function sigma over the domain W. And sigma can be sigma x and y and z, can be density at the point x and y and z. So for example, you can think of a solid that has different density. If I want to find the total mass of the solid, and I'll take the density sigma x and y and z, and then I integrate over the entire solid, and then I'll find the mass of the solid. I'll find the total amount over that area. This is very interesting for engineering questions, because then you will get to basically in multiple occasions. You will need that in electromagnetism, you need that in physics, you need that in engineering, you will need that. So far we talked about approximately what the triple integral is. Now we're pulling out the Fubini's theorem again for triple integrals. This time it says if f is continuous on the rectangular box b equal to closed interval a and b, and then times closed interval cd and closed interval r and s, that is, this one is for x, this one is for y, this one is for z, then the triple integral over the region B, which is this box, is going to be of f of x and y and z, is going to be equal to basically the integral of f of x and y and z, the triple iterated integral of f of x and y and z, where each variable is going to be correlated with the integral and the bounds as it is. So the most inner variable is going to be correlated with the most inner iterated integral, and the second most inner is going to be the most inner, and then the second inner, and then the outer integral is going to be with the outer variable out there. And so how do we take the integral? And so this order, if it's a box, look at this A, B, C, D, R, and S are constants. So if we have a box, the order can change however we want to. So there should be six different orders for that. Now I'm trying to see, here is, that's the first, second, and the third. How do I set up the integral? This goes with x, this goes with y, this goes with z. If I write dx, dy, dz, x should go from 0 to 1, which it does. Y should go from -1 to 2, which it does, and z should be going from basically 0 to 3. Now, how do I take the integral? So how we start is similar to double integral. You find the most inner integral, and here is this one. It's with respect to x, so you take the derivative, antiderivative with respect to x, which is going to be x squared divided by 2, and y and z are the y and z squared are the constants, and then you evaluate at 0 and 1 for x. So x equal to, and when you plug in, you get y z squared divided by 2. So that's the inner integral that we did. And then when you find the inner integral, then you're left with another inner integral. Then you evaluate this one, and this one is again with respect to y this time, and so you will have y squared z squared divided by 4. This time you have to plug in -1 and 2 for y, because we took the antiderivative with respect to y. Oh, this is z squared. And so when you plug in -2 and -1, then you will end up with 3/4 of z squared, and then you take the antiderivative with respect to that and you find the final answer. So let's end this recording using an iClicker question. iClicker question 15.3a. And so it's asking which of the following is not equal to this triple integral. I would ask you to pause the video and think about it and then come back to my answer. So after you pause the video, let's look at this. Here z is connected to 6 and 4 as a bound, y is connected to 3 and 4, and x is connected to 0 and 1. And the only one of these that don't follow that routine is, look at this one, y is within the bound that is asking, z is within the same bound, and so on and so forth. The only one that doesn't do that is this one. X is within 6 and 7, and z is between 3 and 4, y is between 0 and 1. So the answer is C.